So far we've written the locations and directions data as text as well as a binary stream. Right now we read and write each object field individually. For example, we use readInt, WriteInt methods to read and write a locations ID. And we use readUTF and writeUTF methods to read and write a locations description. Now if an object has had 20 fields, we'd actually have to call 20 methods. So instead of that, we can use the object input stream and object output stream classes to read and write objects as a single unit. Now when we write an object to a file, it has to be translated to a format that can be stored to a file and then reassembled into an object later when it's read by an application. Now the process of translating a data structure or object into a format that can be stored and recreated is called serialization. Now in Java, when we want to use an object stream to write and read the objects of a class, we have to make the class serializable. Now we do so by making it implement the serializable interface. Now this interface has got no methods, it's just used to give the JVM a heads up that we may want to serialize the object to storage and to read it back again at some point. Now when we make a class serializable, it's strongly recommended that we declare a long field called serial version UID. Now if we don't do so, the compiler will give us a warning. Now this warning can usually be turned off when using an IDE and unfortunately sometimes off by default, and it will then calculate a default value for us. But however, different compiler implementations may calculate different default values, and that can lead to problems down the road if we change the compiler we're using. Now there are compilers, for example, other than the one included with the JDK. For example, a class compiled with the standard Oracle compiler for a desktop application would be compiled by a different compiler if we were to add it to an Android project. So for that reason, it's recommended that if we care about serialization, we actually set the serial version UID field ourselves. So we set that value. And it's recommended that the field be private since no other class should have to use it. So what is this serial version UID field used for? Well, think of it as a sort of a version number for the class. Now, if we don't explicitly set it, the compiler will create it based on class details such as the number of fields and methods, etc. And if we ever change a class, for example by adding another field or method, or change a field type, we'd have to change the serial version UID value. When we read an object from a stream, the runtime checks the stored serial version UID against the one contained within the compiled class file. If they don't match, then there's a compatibility problem and the runtime will throw an invalid class exception. Now, if we wanted later versions of an application to be able to load files created by earlier versions, we'd have to provide custom versions of the write object and read object methods by overriding them, which are methods we use to read and write objects. So the bottom line here is that we don't have to worry about declaring a serial version UID field unless A, we explicitly use serialization, as we do when we use object input stream and the object output stream classes, and B, there may be a compatibility issue down the road. But some developers and the Java documentation recommend always declaring when A is true, that's when we explicitly use serialization, or whether B also is true. And that's there may be compatibility issues down the road. So with that theory out of the way, let's actually go ahead and modify our code to use the object input stream and object output stream classes. Our first step is to make the location class serializable by having it implement the serializable interface. Let's go and have a look at that. So location. So we just want to change this now. Public class location. We're going to do implements serializable. And noticing that's in the java.io package. Now we don't get any errors about unimplemented methods, and that's because serializable doesn't actually have any. Right, so if we take a look at our location class, we notice that at the moment it's actually got 3 fields, an int, a string, and a map. Now int and string are primitive types, but map is an object. So will that be serialized when a location object is written to a file? Well, in our case it will be, because linked hash map implements the serializable interface. So we're actually in luck here. when we write a location object, the entire contents of the exits field will also be serialized. Now, if linked hash map didn't implement serializable, we'd actually be responsible for writing the code to store its content to the file ourselves. Now, ideally, when we want an object to be serializable, all its fields will also be serializable. So you have to keep that in mind when writing your own classes. If a class we want to serialize will have fields from other classes that you write, then you need to make sure those other classes are serializable as well. But as I mentioned, we're in luck for this application, so serializing location objects to a file will be straightforward. Alright, so our next step is to declare and assign the serial version UID field in location. So we're just going to start by doing that, and we're going to assign it the number 1 because it's version 1. So we'll do that as private long, and it's serial version UID, making sure you get exact spelling there with case, equals 1L. And at the moment, if we have a look at that, IntelliJ is complaining that this field's never used. But unfortunately, that's because it doesn't recognize the field as the recommended one to include with serialization. So next what we're going to do is modify the locations.main method to write the location objects using an object output stream. So let's go and have a look at locations. So we've got our main method here. Now remember that when the class is loaded, the static initializer will run and read the locations from the locations.dat file. So that's this code down here in the static initializer block. So by the time the main method runs, we know the locations are loaded and available to use. So looking at the code that's there now, what I'm going to do is comment that out and write the replacement code. So I'm just going to comment that out so we've got that there. We need to refer back to it at some point. And actually what I'll do is I'll take a copy of this first line because that's going to be the same try with resources. So I'll paste that in, remove the comment. And in terms of writing the objects, we just type for location, it's going to be locations.values, and it's log file dot write object location. But instead of using the data output stream, we're going to use the object output stream, like so. So I think you agree that looking at the code that we've replaced, that we've considerably simplified the code. Now since location is serializable and all the non-primitive fields in location are serializable, all we really have to do is call write object for each location object as we've done here on line 31, and we're actually done. And also you can see that we can use a buffered output stream to buffer the output, so I'm using that there still. So literally all we had to do, which you saw me do, was change the data output stream object to an object output stream as we did there and there on line 29. Alright, so let's now run this locations main method, and this is not the applications main method, this is the main method in locations. So I'm going to right click that, run locations.main. Alright, so that's run okay without any errors. So let's actually have a look at the locations.dat file. So I'm just going to double click that. Now you can see here that it's less human readable than it was before. And in fact, we're getting this error here that IntelliJ is telling us that the document contains very long lines and soft wraps were forcibly enabled to improve editor performance. And also a note here about the wrong encoding. But that's actually fine because a file containing serialized objects is meant to be read by a Java application and not by a human or an IDE for that matter. Now we'll notice that right at the top of the file here, you can see that the package name's there. And if you look carefully, you can actually see there's actually some class names as well. So before we move on to reading the objects, note that the object output stream implements the data output interface and the object input stream implements the data input stream. Now the data input and data output interfaces contain the declarations for the write int, read int, as well as write UTF and read UTF methods and other read-write specific type methods. Because of that, object streams can contain a mix of serialized objects and primitive types. So in other words, they're not limited to only containing serialized objects. In our case, we don't need to mix objects and primitives, but we could do it if we actually needed to. All right, so let's close down this locations.dat file because we really don't need that anymore. The next thing we want to do though is back in locations.java. We want to actually have a look at modifying the static initializer block. And again, what I'm going to do here, I think for simplicity, I'm going to actually just comment out the whole while loop, because that's basically the major part that we're changing there, and I'll just type that in again. First thing we'll do is we'll change the data input stream again to an object input stream and just repeat it. And I'll write it up here, the new code. So we're going to start with while, not EOF, so that code doesn't change. And we're going to add a try. We'll do location equals cast it as a location, lock file dot read object, and print out read location plus location dot get location ID plus a colon there to separate it, plus location dot get description. Then on the next line we'll print found plus location dot get exits dot size plus exits. Then we'll do locations dot put. It's going to be location dot get location ID, comma, and then location. So the error we want to catch here will be a end of file exception. So EOF exception E, and we'll set EOF to be equal to true, which will exit the while loop. And in terms of catching errors, and I might just put this code up the top here so it's all together. We're catching an IO exception, but also we need to catch this exception as well, the class not found exception. So I'm going to do a catch, class not found exception. We're just going to print out a message if that happens. Class not found exception. Do e.get message. Perhaps we'll do that as well if we get one. Okay. So a few things to note. Firstly, once again, I'm sure you'd agree the code has been greatly simplified. We changed the data input stream that was on line 39 to object input stream, but the rest of the try statement pretty much remained the same. And that's because we're still using this buffered input stream to buffer the data. Now, reading a location object, which we're doing here on line 43, well, that actually takes care of reading all its fields and exits. The read object method returns an object, so we have to cast it to a location object, which again we're doing on line 43. Now, once the object is read, all we have to do is add it to the locations map in the locations class, which we're doing here on line 47. We're also printing out the information, as you can see there, on lines 44 and 45. But this time we're getting the values from the location object created by the read object call on line 43. Now, in addition to IO exception, you saw me having to add another catch, which was the class not found exception. And that's here on line 54. Now, this is going to be thrown when the runtime reads an object from the stream and it can't find the corresponding class on the class path. Now, for example, if another application that didn't contain the location class tries to read the objects inside the locations.dat file, then it would actually get a class not found exception. Right, so let's end the video here because it's getting a little bit long. In the next video, we'll come back and we'll run this locations.main method and check that the static initializer block code is actually working as well. So see you in the next video.